So now I would like to introduce our speaker for today, Professor Peter Moonen from the University of Pau and Pays de la Dour in France. I hope I pronounced it correctly, where he's also director of the DMEX Center for X-ray Imaging. And through his work with Excite and with EPOS, Peter helps researchers put FAIR principles into practice and maximize the value and impact of their research data. And today he will share his expertise on FAIR data management and show how researchers can take very simple, impactful steps towards better data stewardship. So please, Peter, take it away.
Well, thank you, Selena. Second. So thank you very much to all of you for joining today on this webinar. What I hope that you will gain from this webinar is that you get some motivation to make your own data fair, that you get some tools to do that, and that you also have interest in what it is to make sure that, or what are these fair data, and how can I help to make sure that other people also make their data. Let's say from my end, I would like to start by asking what your expectations are so that I can modify the content slightly or put different emphasis based on what your experience is. And to do that, I invite you to do one of two things. You can either use a mobile phone and flash the QR codes that you see on the top left of your screen, or you can go to, in a browser of your choice, to the website slido.com and type the number that you see on your screen. So it's 24 29 513. And then you can cast your votes. We'll see the votes coming in live. So I see that up to now, one person voted. You can do multiple votes even. So, and it's entirely anonymous. So make sure that, so if there are multiple things that cover your interests, you can check multiple boxes. 3 people voted, casted their votes. There's slightly more, but we see that there is a general tendency that everybody would like to improve their own data practices. Not everybody, many people want to improve their own data practices, want to support others in making data fair, and that, let's say, the obligation to meet institutional funding requirements is on the low end, or 1/3 of the people, which is actually a good thing, but I'll come back to that in a second. So let's start with the very beginning. The word fair is very much everywhere these days. It's like a buzzword. People often already forgot what it means, but they anyway will use this word. To start from the very beginning, let's look at how we work. And if I say we, then we say, let's say, the majority of the research community. Typical scientific method would be that we start somehow from an observation, and then that observation, you say, this aha moment, where you say, okay, I think this is going on. That's your research hypothesis. And if you have an hypothesis, well, you need to test it. And to test that, you need data. So then you say, I need data. And you're going to look for data. Typically, either you produce them, or looking for these data takes a very long time. But based on these data, you can then test your hypothesis. And as soon as you're very happy about the results and that the hypothesis, the refined version, is confirmed, then you go towards a theory, and that theory you will probably publish in some kind of high impact journal. Maybe because some of these journals, these publishers now, they push you in the direction of also publish your data, please. So potentially this journal publication is supported by something called a data publication. So basically the data that you put out there somewhere. Now, is this a problem? But by itself, the only issue I see here is I need data, and that's time consuming. But where do you get these data? Well, many data, they're not available. They're somewhere in data silos. The typical example that people often use is you're all working at an institution, you have an HR department, you have a financial department, HR knows all about you, and financial department knows all about your salary, but they don't talk to each other. So that's data silos. Everybody works with their own data, and you don't have access to the data of the others. And that makes it very hard to find the data that you're looking for. So discoverability becomes an issue. And even if you get access, then probably the documentation is insufficient to understand what is going on or how you need to interpret this data. And if you don't know what this is about, you cannot reproduce results of others. So given these issues, people posit the term FAIR. FAIR is an acronym where they first say, well, you need to be able to find data easily. If you have found them, you also need to access them, because it's not enough to just know where they are. You also need access. Preferably, those data, you can work with them. You can combine them with other data sets. That's the interoperable part. And finally, if you trust the data, then you also would like to reuse them. And reusing, not only wanting to reuse them, but also be authorized to reuse them. So those are the words that are behind the FAIR acronym. If you look at what is fair, maybe the easiest thing is to look at what is not fair. So many people say fair is a standard. Well, it's not a standard. FAIR is like a guiding principle. It's saying you need to make your data findable. It doesn't say how to do that. And people also say FAIR, that means it's open data or it's free data. Well, it's also not true. FAIR data do not necessarily need to be open nor free. The only thing you need to do, according to the FAIR principles, is being transparent. You need to say, these data are only accessible to the members of my team. And as long as you say this out loud, then it's very clear that the data exists, but that only team members can have access. And maybe you can add, and to become a member of the team, please send me an email and we can chat about it. And then you're essentially doing something that is in the direction of FAIR data. So what is FAIR data? It's a way to manage data. And most importantly, these days, it's adopted by funders, by publishers, and by institutions. So when I said in the beginning or a few slides earlier, it's very good that you're not here because it's an obligation. These funders, publishers, and institutions, they oblige people to go FAIR. And very often, actually, that's the main motivation for people to start. You're already further than that, which is very good news for me, because that we can dive into interesting things. So what is the impact? Well, if everybody would go FAIR, well, what will be the impact, first of all, for you? First of all, in our classical research process, there is this step which is time consuming for searching data. Well, all the time you don't have to search for data, you can use to do more high-level tasks. So instead of searching for data, you could analyze data, which is probably a better use of your brain. Second thing, if people use or reuse your data, they have to cite it in a similar way than if they reuse your journal publications or build on your journal publications, they need to cite them. So also for your own citation record would be good. So it's good for your time, it's good for your citations. And last of all, well, funding agencies require this. So you're also complying with what basically is asked from you. So there is all benefits. These funding agencies, they also have benefits. For the EU, but also for other funding organizations in general, FAIR data is much cheaper. So there was a study published in 2018 that estimated this as 2.6 billion euro per year. And why is FAIR data cheaper? It's because basically we spent an awful lot of time on redoing experiments that have already been done. And we either don't know that they have been done, or we know they have been done, but we don't have access, or we do have access, but we don't trust the results. But whatever the reason, we redo the experiments. And by redoing it, you invest human time, machine time, electricity, whatever. And all that together sums up to 2.6 billion per year. estimation. And secondly, fair data boosts innovation. If you look at the spin-offs, for example, I have a recent number, 2026, a quarter of the European spin-offs are based on AI tools, so artificial intelligence. And the only way how you can make an artificial intelligence seemingly intelligent is to train it on an awful amount of data. But these data, they need to be available. And so by creating fair data, you make data available, and all these spin-offs, they basically benefit from that. You as well, they as well. So from a European point of view, they like spin-offs because that boosts innovation. And on the long run, so not tomorrow, actually, if everybody would do this, there would be a small tweak to the scientific method. You would still start with observations. You would still need to emit research hypotheses. You would still need to test this hypothesis, but now you can use this, the wealth of data that's available. You can use these data publications, the repositories, the data portals. I'll get back to that in a second. And you can use that to test your hypothesis, to refine it. And in the end, that leads you to a kind of insight where you can then publish your reference data set where your insight is based upon. So this is your golden data set, which refers to existing data sets complemented with your own data and your own data layer on top of it. The fact that you are open and transparent about this means that other people could, first of all, build on your work, and secondly, also try to validate what you did and try to replicate what you did. So that's very good. And obviously, once you found something, you can still publish it in a journal publication. And these data, they are out there. So people that want to start up a spin-off, not necessarily in AI, but can be in any field, they can just use the data according to the licenses associated with them. And we'll get back to licensing also in a second. So we talked about fair data, but what is it that makes data fair? So not all data is equal. First thing, the F was for findable. There are different cases. The first case is, I know what I'm looking for. It's the data set that was made by this person at that time when he was at that lab. And so a data set, when it's published, it has a DOI, digital object identifier. So you just Google or whatever search engine you prefer, you search for the DOI, and you will find the data set. If you don't know the DOI, but you know more or less who did it, when and where, then you can just simply search the repository. So the repository is the place where all these data sets are put. One example is the GFZ data services repository, one out of many. One out of many makes it also difficult because you need to know in which data repository you have to search. So therefore, you can zoom out a little bit more. You can be interested in specific data from your domain. For example, I need chemical data on some specific rock. Well, then you can go to domain-specific repositories, and what they do is collect everything on, for example, EarthChem that I cite there. It's all the chemical information on Earth materials that is grouped at one single location. So there you will probably find what you need. If you want to go even larger, like you're a geologist, you want to know something about the chemistry of your samples, but also something about the physical properties, and also something about some X-ray images and some SEM and so on. Well, then you can go to a data portal. So what is a data portal? A data portal like EPOS MSL is a place that does crawling, so it's going to search in specific repositories. And so it can be institutional repositories like the GFZ data services that I just mentioned, or it can be domain-specific like EarthChem. And it's regrouping them in a single portal, so a single gateway to data. In that way, you don't have to worry about where these data are stored. The portal will look at it for you. So, and then you go to the most general scenario. I'm interested just in multidisciplinary data across many domains. And so here you end up with the overarching data portal, like there is ICSC, but essentially you can compare it to the Google of data. So you just go and look for data. It's casting a wide web and finding back stuff. Obviously, the larger you go, the less details you can have in your search terms. So the better is you need the highly detailed stuff in a, let's say, a institutional repository or in a small repository, and then somehow keywords get lost along the way. So it's always good to go back to the source data or to be as specific as possible when you're trying to find data. So what does it need to find data? Well, you need to put them in a repository. Otherwise, well, if they're not out there, nobody can find them. But then there need to be, I already mentioned the word keywords. The official term for keywords would be metadata. So metadata is the keywords associated with your data, and they have to be as rich as possible. So the better you describe your data, the easier it gets for people to find it. These data, they have to be readable. If you use some Chinese character set to use it, then only a specific limited portion of the population will be able to read it. And it's not only humans that need to read it, it's also computers. So the best thing to do is use some kind of ASCII file format like the TXT files, because those type of files and encoding, they are readable by basically any machine and every human. And you also need these DOIs. DOIs, digital object identifiers that don't change. And the infrastructure, obviously, that we already discussed. So that's findable. Once you found it, you need to access them. But you need to know how they can be accessed. So how means if you go to any website, you will see that probably it starts with something like HTTP or HTTPS or FTP if it's not a website but a file server. HTTP is Hypertext Transfer Protocol. The S is for secure, and FTP would be like a file transfer protocol. So you notice there's P in every one of them. It's protocol. Protocol is basically how do I bring data from the server to your web browser. And so people agreed on how to do that. And whether you like the Chrome browser or the Edge browser or whatever browser, everybody agrees on this convention on how these data need to be read and transferred. And that's why you have access. If this convention wouldn't exist, then everybody did something and it wouldn't work. And then a point that we already mentioned, fair data does not need to be open. You just need to be transparent about the access requirements. It can be that you need to create an account. It can be that you need to pay. Obviously, it's better that your data will be more reused if everybody can access them and if they don't have to pay, but it's your choice. So you just need to be transparent about it. And the metadata, that's important, they need to persist even if you destroy the data. So you always need to keep track to have about like, here there was a data set that was describing X-ray data of a Bentheimer rock at 5 micron resolution. And it was accessible for people with an account, but now we removed it. At least you have a landing page. Otherwise, you just get an error. Like this, if you surf for websites, you sometimes see this 404 error page. That's that a web page doesn't exist anymore. Well, you want to avoid that. So the data set is gone, but you still have tracked that there ever was a data set which had this content. Okay, so then we access the data. Preferably, you want to source data from different sources and then merge them together or do something with them. That's what they call the interoperability. And so to make it easy to understand, if I'm from an imaging site, but everybody can imagine something behind the word resolution. If I download two data sets, and the one is at 5 micron resolution, and the other one is also at 5 micron resolution, according to the metadata, then I hope that the two are actually at the same resolution, that people mean the same thing when they speak about resolution. If you're a little bit in the field, you know that there exist as many definitions of the word resolution as there are people on this planet. So you need to agree on the language, because once you start putting numbers behind it, the resolution is, and people trust that number, then they need to know to which definition it corresponds. So that language, that is called the vocabulary. And also the vocabulary need to be clear. You need to agree on what the vocabulary is, just as you needed to agree on the HTTP protocol to be able to see your websites. So the vocabulary, let's say the definitions that you should use, they should also be available, and you should be able to access the description so that you know what it means or what people mean when they use the term resolution. And we also already mentioned, probably you're taking different data sets that already exist and you complement it with your own data. Well, you also need to keep these links alive. You need to refer to the DOI of the other data sets, or the PID is a different way to say DOI. It's a more general term to say it. It's the persistent identifier. And DOI is one persistent identifier, but not the other. Okay, and finally, you want to reuse that data set. And then we come to, can you reuse it and do you want to reuse it? Well, maybe let's start with the legal part. Can you reuse it? Well, you can reuse it if the author of the data allows you to. Very often, and you see it also on the pictures that I've included in this slide, there is like a little CC0 logo on them. So CC stands for Creative Commons, and the 0 means there is no rights retained by anybody. So they're free to share, free to reuse, free to do whatever you want. But you, as an author of your data, you can decide what people can do. For example, a CC BY is another very popular license. CC means essentially everybody can reuse it, but the part BY means by somebody. So you need to cite the author. This data set, I reuse it, but it was made by Mark or by Jessica or whatever. So you need to cite the author. And you have other licenses like that you cannot use it for commercial stuff, but you can use it in academic or whatever. So many options. You have to clarify the provenance of your data. So you work on data that come from other data that built on other data. So this has to be clear. And obviously you cannot sell the work that others have done. So you can only put constraints on your contribution, not on the one that others have made. And then, so that's if you can reuse it. Then is still the question is, do you want to reuse it? Well, personally, if I get a data set from somebody else and there is like 10 spelling mistakes already in the file name and there is no explanation on how these data are structured and it looks like a mess, then I have absolutely no confidence in this data set and I don't want to reuse it. On the other hand, if I get something pretty structured with a nice text file that is explaining like I obtained these data in the context of this project and they come from there and this and this and this, like a lot of explanation, then I say, okay, this looks like a decent person. I'll keep this data set in mind and I'll use it. And if something comes out of it, I'll cite the person happily. So that's the one thing. And people will not reuse your data if they're a mess. So, but also for yourself, if you make them clear, then probably they're good. So now it's back to you. I explained to you what these FAIR principles are. Some of you indicated you would like help with making your data more fair. So what is the hardest one for you? Would it be making data findable? Would it making them accessible? Would it be making them work with other data sets, or would it be reusing them? It's for you. It's not a general thing. We have one vote, so that's per definition 100%. So interoperability is the key one currently. And probably I understand this reaction, because if you want to find data, it's basically not so much your problem. It's there are these data problems, there are these repositories. They do a hard part of the job if you added keywords. And keywords are also the key behind interoperability. If you want that people, that your data can work together with other data, then you need all these different data sets to speak with the same language. And that necessitates or requires a community that speaks the same language. So interoperability is very much a community effort. So that's what we're trying to do with Excite. It's what EPOS MSL is also trying to do. And if you're interested to contribute to that, then be our guest. We're very happy to have more people that give their opinion, because vocabularies like the keywords, they need to be really community supported. Even if you have a term that is pretty much, well, I can call my first variable A, the second one B, the third one C, and as long as everybody knows what it means, A, B, and C are perfectly fine, but they're not intuitive. So the best thing is that you have a community that makes intuitive vocabularies that you can then use. And if everybody uses them, then by definition, your data will get interoperable.
Still there?
So,
there you are. You were glitched a bit. I was just wondering, because you mentioned that if people would like to contribute, that they can. So can you maybe also tell us, or maybe we can share later on after this webinar, how can they contribute to that? But maybe for time's sake, maybe just continue and then we'll get back to that later.
My last slide in either case contains my contact details, so people can always contact me, and not only about contributing, but also if they have questions. But we'll come back to that in a couple of slides because we're almost there. So the last part is, well, time to act, doing something. This is called Fair Data Stewardship or Fair Data Ambassador. So what does a fair data steward do? Well, three things. He does data management during a research project. He does the data preservation after the research project. And he applies these FAIR principles when he's handling data. So if you do this, well, you're probably doing research projects. So you will basically say, yeah, but I'm actually doing all this already. Maybe not the FAIR principles, but you're already handling data, you're already putting them on a hard drive when the project is finished. So you essentially are already data stewards. So the question is whether you're fair data stewards. So let's go a little bit more in detail. So what do you do during a research project? And so the best thing to do is to make a data management plan. It's a DMP. It's a document that tells you how you can handle data throughout the life cycle of a project. And often I hear people say, oh, but it's research, I don't know. Okay, very good, fair. But take it from the other side. If you're going, the questions you need to ask to yourself is, which data do you want to acquire? You start a project, what are you going to do? Okay, I want to go to the synchrotron and I want to get X-ray data. Okay, very good. How big will this data set be? One data set is maybe 100 gigabytes. I will have hundreds of those, so 10 tera, 20 tera, something like that. Okay, then how will you store that data? I'll go there with the hard drive. Do you have hard drive of 20 terabytes? No. Okay. Okay, I'll bring 4 of them. Very good. And then what will you do with this drive? Who can access it? Will you then distribute it with your colleagues? Yes, no? Because hard drive, not so easy. Maybe data server is better. So you just think about the practical stuff of what you will do. And obviously it's research, so your plans will change. You don't have beam time, but you notice you can use your data, obtain it with another technique. Well, then update just the plan. That's it. So this is a data management plan. In the beginning, it's very hard to write this, but there exists help for that. There you see a number of lists, a number of terms like DMP, Opidor, DMP Online, Argos, Data Stewardship Wizard. Type this into your favorite search engine, you'll end up with a kind of wizard or template that you just have to fill in. But the key thing is just think about your data, and then you avoid problems. You don't do your long experimental campaign then just to discover that you don't have a hard drive to store everything, or that you cannot read it in a decent time before the end of the day. So, okay, that's during. What do you do afterwards? Well, afterwards, you need to decide whether you will keep the data or not. Typically, people don't decide anything. They just keep it on the hard drive and then they forget about it. But the better way to do it is to think on which data do I preserve? Do I preserve the raw data? Those ones I can always do new analysis based on the raw data. Do I only keep the published data? Do I, whatever. If they're on a server, you probably, or on a cloud, then probably you pay per gigabyte or per terabyte. So there is a cost associated with this solution. You also need to decide on the format. I did my master thesis a long time ago, and I had files, figures made in Origin. But now in my current affiliation, I don't have access to Origin anymore, so I can no longer open these figures. That's pretty sad. So I should have saved them in a JPEG format, for example. If you're dealing with specific data, think about anonymizing them, because if you store like sensitive information on a hard drive that you forget in your cupboard, not a good idea. Documentation is also a good thing. If you 2 years later you take your data back, you look back at them, you forgot probably what you did, and if it's somebody else that did the analysis, then you're completely lost. So think about all this. Typically, you write that already in the DMP, and instead of dumping it on your own hard drive, dump it somewhere in a repository and add a README file. If you don't know which repository would be good for that, I share you two links, these re3data.org and fairsharing.org. And there, based on keywords, you can find the repository that is the most suitable for your data set. So just don't keep it in your office, dump it there. And finally, data handling. Well, also there, this fairness in the beginning, it's very time consuming, it's very complicated. Once you're a bit dealing with it on a daily basis, then you notice it's not so hard at all. You just need to be organized. That's the only thing. But if you need tools to do that, well, I share two links here, How to Go Fair and gofair.org. And they provide like links to other web pages and to little tools and to small pieces of software and whatever that can help you on implementing fair data principles at your workplace. So you see that if you feel tempted to start doing this, maybe then afterwards you will feel tempted to speak to other people that didn't attend this webinar, to tell them to re-watch this webinar. And if you do that, then you're basically becoming an ambassador for fair data or a fair data ambassador. So it's time to wrap up. The takeaway messages from today were that fair data, it's a mindset. It's being organized. It's being respectful towards data. It's not a checkbox. It's not like your funding organization says my data has to be fair. I need to make a DMP. Okay, check, I made a DMP. And then it's a document that you forget that you made it. That's not it. Also, fair data, you can go very far in this, but it's not needed. It does not need to be perfect. Then you will get exhausted very quickly. Just try something, add a little bit of explanations, and a little bit of explanation is much better than no explanation at all. So just try something and it will already be better. And next time you'll make it even better. And you're also not alone. There is support available, there are resources available. So I gave you some links already throughout the presentation. Here you get some others. It's really how to get started. Can send, or the presentation will be sent to you afterwards, so you will be able to check out these links if you want to. So to conclude, if you would need additional support to make your data fair, you can indicate it in the upcoming poll. You can also send me an email, and you will anyway receive a follow-up message that answers your questions and that tries to get you started. So with this final poll, I will try to end this talk, and if you have questions, feel free to ask them in the meantime. So this is what kind of support would you need. It's about training materials, it's about policies and intensive, about the tools that you can use, or it's just more like the community feeling and the peer support from that community. Thank you all, and if you're having questions, don't hesitate.
Thank you, Peter, for this very interesting and very practical webinar. I really enjoyed it. So I see that we went a little bit over time. Of course, if you have any questions, please put it in your chat, in the chat or the Q&A, or raise your hand. We're also very interested to see what kind of support would help you verify verify. That's an interesting word indeed. Your data. So, Peter, I was really interested. So, this is also how do you say? Gewetensvraag, we say in Dutch. So, if you could change one thing about current data publication practices in your field, what would it be?
Oh, complicated question.
So, how long do you have? Yeah.
No, it's actually the things we want to change, we are already changing. That's the good news. It's
fantastic.
the collaboration with so I'm from the Excite side, but the collaboration with EPOS is basically tackling exactly what is now on the top of this poll. So we also think that if people want to, if we really wanted people get their data out there, probably they have to see the use of it. And how can you see the use if you yourself never find a data set or reuse a data set? So we're currently working with EPOS on a more visual search engine for imaging data. Will be available in or the alpha release or beta release, I don't know, will be for the fall somewhere. And that will allow to find data. And if you find data that are just by you hear from somebody, you try it, you say, oh, looks nice, and you do something with it, then maybe next time you feel more inclined to contribute your own data. So I think the things we want to change, we're already doing that, making sure that people see the advantage.
That's great news in that sense. So you're actually changing things that you want to have changed, you do it yourself and put it into practice. So that's great. And indeed, this is coming out. I think it is planned for Q4, so the last quarter of this year, like around fall. And if you would like to have a look and also be included in how do you say the trial panel,
Don't
then
hesitate.
please give us some feedback on how the new tool, the innovative tool that we were developing together with EPOS indeed works. Please let us know, and of course we will let you know how you can contribute to that. So if there are no further questions, I would like to thank Peter today for his really nice webinar today, and thank you for being here on this very warm day, and keep it cool today. And have a great day, and see you next time, hopefully next week for the webinar, which will go a little bit further into detail on the data publication workflow we have also developed.
Which keywords to use, which
so it will go into more
repositories to
detail on
use,
these
which
different
license to
steps,
choose.
right? Yeah. So I hope you will be able to join us again also next week for more details on how to get your data more fair. And thank you very much. Have a great day.
Bye-bye.